So guys, here as you can see that I have used these two single strand copper wires to hold the brushes back in their place because they were not allowing the commutator to get in this slot. Before I do that, I will also have to place it in this. Yeah, now it's gone, and now I can take it out, this one as well as this one. It's in contact with the brushes. Now it's time finally to place the rotor back in the field. Well, it's not very smooth. Seems like there is some problem with the bushes of the armature. So guys, from the previous video, your question for today is what was the maximum weight that I pulled with the photocopy machine motor? So guys, the motor was not working properly. You see this was connected here to the shaft at the back, and there was another piece but it was missing in the motor from the beginning. So I had to make this other workpiece, and this piece is like perfect for this, and all the dimensions are matching 100%. You see that plastic bore, in that I have to place this back of the shaft with that holder. So let's do that. Nice fit. Now let's tighten up the screws and see how it performs. Somehow the motor was lying around and not working, like thrown away, and it also had two missing screws, which means that it had been opened initially, and during the repairing the repair person lost the piece. So guys, the motor is fully complete now, and you can see that I've placed two more screws. You see, little different, but yeah, they fit perfectly, and now it is running pretty good. Let's test it with a 12 volts battery. And guys, now I have another beautiful motor in my collection. Pretty good performance. It's running really nice. Hi guys, you are watching channel Mr. Electron, and today I'm going to show you an amazing motor, which is this one, a high torque 43 kg centimeter motor. And this head that you see, that is the gearbox. Now of course in the video I'm going to show you which type of gears have been used in the gearbox, like if they are metallic or if they are nylon gears. Plus I'm going to make an amazing project with this motor. It is 24 volts and 5 amperes motor with 150 rpm. So let's get started. Okay, so guys, it's time to open up the gearbox of this motor. Let's see which type of gears have been used inside. Well, seems like I will have to use the old method. This one. Yeah, this one was easy. This one is tight. Oh, very long screws. You see? Was really tight. Two more to go. So guys, the screws have been removed. It's time to open the gearbox. That's the motor, and inside is the gearbox. So I have assembled back the motor once again, and now it's time to start the main project. Now guys, if we look closely, these are the high quality screws that have been used for the motor. Now the motor itself, the label, as you can see, 24 volts, 5 amperes and 150 rpm. Since the rpm is low, therefore the torque is obviously going to be really high. Company is Tokushu Denso Tokyo, Japan. Gear motor, and yeah, 43 kg centimeter torque, 1:24 gear ratio, DC 24 volts, 5 amps. So that's the label, and the front, as you can see, it's written made in Japan, and it goes to Denso Co. Limited. And that's the motor shaft as well as gear, and the bearing, as you can see, it's flashing Thailand and Z809. The gearbox itself, here we have the shaft, and I don't know the use of this. I think some kind of belt was on this disc, and you can see the gears moving when I rotate the shaft like this. It's quite smooth, really smooth. Let's take out the gearbox. Now comes the difficult ones. Let's see if I can reach there with this. Now the other one. Yeah, it's out, yes. Oops. I think I will have to use some kind of wooden platform. It's going to get messy over here. I it's still not coming out. Yeah, actually now I think that the only possibility is to take out this disc, and then it is going to be taken out from the back. Now that is going to be very difficult since this is all rusted. It's an old motor, so I cannot go through all that, but you can get an idea of how it looks from inside. Yeah, seems like that's the max I can do, and opening these screws was not enough. So let's place them back. So guys, finally I've placed back the gearbox and it's running smooth. Now that's the motor that you already know. Let's give it a spin with my 12 volts UPS battery. So although this is a 24 volts motor, let's test it with 12 volts and we can get an idea. You can see pretty high RPM and torque as well. You can see the motor jumping because of the high moment of inertia of rest. Here, as you can see guys, that I've placed these two holders, and it's going to be placed somewhat like this. So let's mark the points. As you can see guys, that the metal piece is really thick, and here as you can see the cut. And you can see that it is through the metal piece, the thick metal piece, and it is very straight. Hi guys, you're watching channel Mr. Electron, and this what you see is a very powerful brushless DC motor that I salvaged from a Xerox machine or an old photocopy machine, and I did a few tests and I salvaged it and restored it into a good working condition motor by replacing the previous installed circuit. If you want to watch that video, link will be provided in the description below. Do check it out. Today in this video, I'm going to use this very generator to produce large amount of electricity. The best part is guys, you see this head. This is the gearbox, the reducer gearbox, because of which the RPM is only 180. It can be used in low RPM applications in case of generators, okay, like wind turbines or hydroelectric generators, where the RPM is low, but you have large blades for the starting torque, and then it is going to generate huge amount of electricity. And the best part is that it has no brushes because of it being a brushless motor, long life, mounted on bearings, and still very healthy. So in this video, I'm going to conduct a few tests on voltage, current, both open and short circuit, and maximum power rating as well. The shaft size is 10 mm and it is quite long, so it is again very useful. So let's get started. So guys, this is a crank, the handle that I'm going to use to attach to the shaft of this motor for testing it. And the shaft size is almost 10 mm, which is quite nice, and also its length is like this, so it is not going to get in contact with the base. Yeah, now it should be ready to go. You see, smooth. Wow. uh, the best part that I love about this motor is that it is so old and still it is so smooth. The bearings are so nicely made and high quality. It's really easy to turn it. Yes, it's not loaded, but that would not be the case for bearings. Okay, so let's do some measurements. Now guys, you see these three wires coming out from this generator. Okay, so these three represent the three phase. I am going to connect only two wires to this multimeter that you see because it can measure only single phase voltage. Okay, so I'm going to choose these two. And let's point the multimeter towards AC voltage measurement mode, and this will be our single phase voltage. Okay, so 17 volts was the maximum AC voltage that I could produce on open circuit with this generator. So guys, now comes the part of measuring the short circuit current of this generator. But the open circuit was easily measurable with the help of two wires. But for short circuit current testing, I will need a three-phase AC to DC converter or bridge rectifier, and this time I'm going to utilize all the three wires. So guys, it's time to connect the three-phase wires. These what you see, this blue one and this red and this black, these three are the three-phase input, and these two thick wires that you see, red and black, these two are the high current DC output. So finally we have converted AC to DC. It's time to test it. Now these wires are not needed, and this meter can also measure DC current, which is the best part, with the help of this clamp. Okay, link will be in the description if you want to buy it. Pointing the meter towards 600 amps current mode. So to measure the short circuit current, you can see I've clamped the meter to one wire, but we will also have to short circuit these two terminals, the red and black, and then the current is going to flow and this meter is going to read it. So we are going to need another clip, and here we have another clip. Okay, and the wires have been short circuited. Okay, so this time the motor is going to be really loaded, so I will have to hold it strongly and then move it, and still it is going to be very difficult for me to turn the shaft. Okay, the amperes have increased to 1.48 amps. It's little tight, but not that much. I can easily reach around 2.5 amps, and it is very tight now. More force is needed. Around a 4.8 amps I have reached yet. 5.2. 6. 6.96 amps, I think it was. Yeah, so 6.96 amperes was the max I could do with hand crank rotation, and I cannot continue doing that for long. Now let's move on to actual load testing. Let's start with this car headlamp bulb, and its rating is 100 watts. You see, 12 volts, 100 watts. Let's keep the meter aside. Yeah, got the second one too. Okay, so both the clips have been connected. You see that it has started glowing. Let's turn off the lights. Okay, I'm going to start turning it now. Bulb is glowing really bright. Once again. Wow. But yes, it was very difficult to turn it once it was loaded. Although guys, it is going to be much easier to blow this 35 watts bulb. Now guys, the connected bulb is only 35 watts, so this time it should be easy, not 100 watts. Let's see. Yeah, it is really easy. Oh wow. Very easy. Well, I can easily glow it to full potential without even standing. You see, let's turn off the lights and see this time. Okay. Simple turning and it starts. No power at all when compared to the previous bulb. The previous bulb was around 3 times more powerful than this one. Yeah, I can even fuse it. You see, simple turning and it is glowing. Wow. So guys, when I was there outside searching for other stuff that I can glow with this generator, it just struck my mind that this generator produces 3-phase AC. So what if I utilize just one single phase AC and step it up with the help of a 12 volts to 220 volts transformer, like a UPS transformer, and then power up 220 volts AC loads directly without any battery or any other conversion circuit. That would be interesting, right? So it seems like that I found one UPS transformer 12 to 220 volts. So let's connect it. As you can see that like this wire and this wire, these two are really thick, and these two are like red and green, very thin. So obviously these are high voltage low current, and these two are low voltage high current. So connecting any of the two wires from this generator, let's remove this one, and I'm going to choose these two and connect them to the low voltage side of the transformer. So guys, here what I have is a big 18 watts LED bulb. So I'm going to start with this one. And then move on to the next higher load if I have it. With that being done, let's start the turning part. Oh, you saw such a simple turn and it started glowing. I didn't even think about that. Wow. Yeah, as soon as it starts glowing, this generator is getting loaded. But once it turns off, again, the load becomes very less. So let's give it a fast spin to see if it can glow continuously. Okay. Oh, yeah, it is little tight now. 20 watts bulb. Yes, but it is working. Continuous output. Let's turn off the lights once again. It is turning out to be an interesting experiment. So guys, the lights are completely out. I cannot see anything. Well, I'm going to grab the handle. Yeah, got it. And that's the motor and that's the gear. Okay, yeah, I think I've got it. Let's turn. Whoa. Oh, wow. Isn't it so amazing? Oh, it's very bright. And it's not that hard. I'm sitting over here and then I'm rotating it and still it is glowing pretty bright. But as soon as I like reduce the RPM, it stops glowing. I have to keep it steady. Okay. Yeah. Yeah, but it works really well. Seriously, guys, that was an interesting experiment. Oops, lights are gone once again. Let me turn on. Hey guys, look what I found. An induction motor fan. Well, I'm not sure if the single phase output of this generator is going to be enough to start it, but there's no harm in giving it a try. Let's see if it can spin it. So let's start with the turning part. Okay, keep watching that. No, nothing. You saw it started running. Once again. Oh, it is running very slowly, but yes, it is running. Let's move in fast. Yeah, this generator was able to start this one, but yeah, obviously the output power of this generator is might not be enough because I'm only utilizing one phase out of three. Okay, so one phase, and after that transformer losses, and then again the worst induction motor losses. Did you know, guys, that in an induction motor 40% of the received power is lost as heat and the remaining 60% is the only power that is driving the fan or the load? Okay, so that is why I like seriously don't like the squirrel cage induction motors. There are a lot of losses, and the torque is also not that good when compared to the slip rings. In any case, even if it is a slip ring induction motor, still it is going to have better torque than this one. Hey, look what I found. 200 watts Ferox LED panel. Yeah, the transformer output has been connected, you see here. Okay, to this LED panel. Let's start it and see if it can glow this. It is glowing. It's dim, but it is glowing, and now it is very bright. Let's turn off the lights once again. Oh, again. And here we have, you see, when I turn it very lightly, then it is glowing, not that bright. Okay, but let's turn it faster. You see, it is much brighter, very bright. Light, medium, okay, and bright. And it is very easy. You see, I'm sitting over here and turning it, and it is glowing pretty bright. Fire! Wow. So anyways, guys, that was all about the video and this experiment.